All right, I'm not going to work through all these, but just help you get started. Questions 1 through 5 are obviously on percent error, which we can see right here. All right, for percent error, it's an equation. Percent error equals your observed minus your accepted divided by the accepted times 100. You'll remember that from your notes. All right, so let's look at number 1. It says the literature value. The literature value must be the true or closest value, or most accurate. So we're going to say that's the accepted. Put a little A. The literature value of the atomic mass of an isotope of nickel is 57.9. So there's the accepted one more time. If a student determined, all right, so that must be the observed, the mass to be 59.6 grams per mole, what is the percent error? All right, so there's your O. All right, I'll put a B so it doesn't look like a 0. All right, so we just plug this in. So for number 1, our observed, 59.6, minus our accepted, 57.9, divided by the accepted, 57.9, times 100. All right, let me type that into my calculator. If you have your calculator, go ahead and type it in also. I get 2.93%, 2.936, since there are 3 sig figs in all these numbers. I'm going to say 2.94%. That's the percent error for number 1. All right, number 2, 3, 4, and 5, you follow that same thing all the way down. Just make sure that you know how to determine which is the accepted and the observed. Just to help you on that, let's look at number 2. At 20 degrees Celsius, the solubility of potassium chloride is actually 34.7, so that must be the accepted. All right, so that's our accepted, grams per 100 centimeters cubed. A laboratory experiment, so this is going to be the observed, 32.3. You can plug everything else in here. This is a classic chemistry problem that confuses people. There's lots of extra numbers in here that don't really matter for the actual problem. Like, we're not going to use the 20 degrees Celsius because it has nothing to do with percent error. We're not going to worry about this 100 per 100 centimeters cubed. In chemistry, things are always performed at a specific temperature. Rarely does that temperature affect the math in the problem. And this is just telling you how much goes in to 100 centimeters cubed or 100 milliliters of water. So what really cares is the 34.7, that's our actual, our observed 32.3. All right, now one of these, number 5, is pretty easy. See if you can do number 5 and determine why it is so easy.